I'm going to be going over some strategies that your students might want to use as they begin to navigate the courses using the Sphero robot. First strategy I want to talk about is using a tape measure or a yardstick to determine the distance the Sphero will travel with a consistent command. So for example, the command that I have listed here, command 1, speed is 30%, the heading is 0, and the delay is 1,000 milliseconds. So what I'm trying to determine is what will the distance traveled be according to this command. And then once I know that distance traveled, I can use that to help measure other portions of the course and more accurately decide on what my next command should be. So let me explain how this would work. You could have your students do this on one of the courses, or they could do this just off in some extra space that you may have around your classroom. It could be in a hallway, it could be in your gym. The first thing they're going to want to do is they're going to want to mark the starting location of your Sphero. Make sure that you go ahead and put in a command. The one thing to make sure that stays the same would be the speed. And I don't care what speed you're going to use, just remind them that whatever speed they do this first test with, that's the speed that they use for their entire course as they test. So for example, if I tested this speed of 30% and a delay of 1,000, and let's say I got 18 inches, that was the distance traveled, that's going to change if I increase my speed to, let's say, 40 or 50%. So they need to remember that whatever speed that they test this distance with and measure, that's the speed that they need to continue to use in the rest of the course. So they've got this first command, they've gone ahead and set their Sphero at the starting point, they mark that starting point, and they made sure to orient that Sphero so that the taillight's facing them. They can go ahead and press the play button and let that first command execute. Let's say that Sphero goes to this position and stops at the location that I just placed it. What they're going to want to do is they're going to want to mark that location. So now they have two spots marked on the floor. They've got their starting location and the end location. Now what they're going to do with that tape measure or the yardstick is they're going to go ahead and measure the distance from start to finish. So we use this green line to use as like our yardstick or our measuring stick, or I should say measuring tape. Let's say that they found out that that distance traveled, as I mentioned earlier, was a total of 18 inches. Now they know that with this same command, every time that they put a speed of 30%, a heading of, I guess you could keep the heading at 0, whatever the heading is going to change to. It could be at 90, it could be 180. Any of those headings, that's not really going to affect the distance traveled. It's going to be more around the speed and the delay. So with that speed of 30%, the delay of 1,000, we can always conclude now that if we have 30% speed and a delay of 1,000, the distance traveled is going to be 18 inches. Now I'm not saying that's going to be entirely accurate every single time. Maybe it's 17 inches one time and then maybe it's 19 inches the next. However, we could probably assume that it's going to be relatively close to 18 inches. There's going to be some room for error because it's going to take some time for the Sphero to always start, and it can't stop immediately. Just like a car, if it's going from 0 to 60, it can't just automatically go from 0 and magically be at 60 miles per hour. So there's going to be some time that it takes for it to initially get going, as well as it's going to take some time to stop as well. So this distance might change a little bit, but that's just going to be a good reference for us to use that with this command. Let's say it did travel at 18 inches. So now what students can do is they can use that reference as they begin to measure the rest of the course. So for this course, let's say that they measured this next straightaway that they had. And let's say that they found out that this straightaway was a total of 36 inches. So now they found out that this was 36 inches, that they had to try to make their Sphero travel. So let's say that, we'll get this red line out of here. Let's say the Sphero is at this location and trying to navigate clear to the end of this straightaway. Well, they can start with a better guess since they know that this line, the green line, is 36 inches. If they know that 18 inches means that the delay was 1,000 milliseconds, this can assist them as they determine what their next command should be based on that distance of 36 inches. So if 18 inches is the same thing as 1,000 milliseconds, we should technically mean, or that should technically mean that 36 inches would be a total of 2,000 milliseconds. However, like I mentioned earlier, there's going to be a little bit of variation just because the Sphero is going to take some time to start and stop. So if they know that this green line is 36 inches, which should technically be 2,000 milliseconds, they could use that information to go ahead and type in command number 2, which would then still have that speed of 30%. If I could type, wow, and a heading of 0 again, since they're going forward, and a delay this time of 2,000 milliseconds. So they used that distance that they measured earlier to assist as they programmed their command number 2 for the Sphero to complete this straightaway. Now you might find out that this green line, since it went from this white line here to the white line at the top, but we don't want the Sphero to go from that white line clear to white line. So they might have to make an adjustment to this delay slightly to actually get that Sphero to stay within the boundaries of that tape. But this is just one strategy that they could use to assist them as they decide on what should the delay be as they navigate these courses. Now, I also mentioned a strategy of using fractions to help them decide what command they should add when they're programming the Sphero. So let's start back at the beginning, and we'll stay with that first command that I had of speed of 30%, heading of 0, and a delay of 1,000 milliseconds. We'll go ahead and delete this second command because technically the Sphero needs to do command 1 here, command 2 here, and then this would be command 3. So earlier when I said this would be command 2 with the green line, that wouldn't be entirely correct. We're just using that as a demonstration for this strategy that we're talking about. So fractions, how do we use fractions to assist with solving some of the commands that we need to successfully complete the course? One thing you can do with fractions is, let's say we kept that same command 1 and we went ahead and played that command, and we found out that the Sphero stopped in that location. Now we used this red line earlier. Get that red line. We used that red line earlier to measure that distance between start to stop, and we figured out earlier that that was 18 inches. Now if we were to take and measure, let me get this red line out of the way. Let's say we measured with this blue line, and we wanted this blue line to be the distance that we need our Sphero to travel. So we're going to go from here, and we want the Sphero to end up here for our second command. So it's not going to travel very far, but we need that ball, or the Sphero I should say, to travel this distance before it can actually begin going down this straightaway again. So one thing that we can do with fractions, if we broke this down into a fraction and thought from start to 0 to finish it to 1, so this distance, we'll get our green line back here, let's say that the distance between that, like we discussed earlier, was 18 inches, but let's just think of this as a fraction. If we were trying to discuss that half of this would be in the middle, and then half, I shouldn't say half, but you could say half of the half would be a fourth. So we could say between there and there is a quarter, and then down here is a quarter. So if we broke this into 4 equal pieces, here would be a quarter. We could say then that this might be a half-ish, and then there would be 3/4. So if we broke this down, and we were to take this line, and we'll rotate this line, because remember, this blue line was the distance that we wanted our Sphero to go from the middle location to the middle location of this straightaway. If we brought this blue line down to our green, we could say that that fraction that we need, if you compared that, remember this was a quarter, this was a half. So if we know that this is a half, that blue line was, we'll rotate that back so you can see. If we move that back up here, that's a half. That's the distance we need our Sphero to travel. Well, a half, if we remember, originally the command was 30%, heading of 0, and the delay was 1,000 milliseconds. So if we know that's what our Sphero did for this first command, but now the fraction that we found was it needs to do half of that first command, that doesn't mean our speed needs to be 15%. That just means we need to focus on the delay, because remember, the speed's going to stay the same. It's that delay that's going to change. So this is where that fraction comes into play, that students could then determine that with command 2, that the speed will stay at 30%. The heading this time will change since we're going to go to the right. The heading of a right angle would be 90 for this turning the Sphero to the right. And then the delay is what's going to change as well. And this is where we use that fraction to determine 1/2 of 1,000 ends up being 500 milliseconds. So that's how you can use fractions. Not that they're going to draw lines on the floor. They're just going to visually be able to see that the distance that the Sphero traveled initially, and they can measure kind of with their arms as well to try and get a better idea of is this half the distance of the first command? Is it 3/4 of the distance of the first command? But they can use fractions to assist as they begin to add more and more commands to successfully navigate this course and end up at the final location on that course. So again, those are two strategies: having them measure the distance the Sphero will travel, and then using fractions to assist as they add commands.